Wyatt Roy, MP, distinguished guests, ladies and gentlemen, welcome to tonight's Innovation Lecture. Before we begin the proceedings, I'd like to acknowledge and pay respect to the traditional owners of the land on which we meet, the Gadigal people of the Eora Nation. Mr. Roy believes that for Australia's quarter century of uninterrupted economic growth to continue, an innovation ecosystem must be fostered where new businesses with never-tried ideas are encouraged to take risks, grow, and employ. And that's an idea that we strongly endorse at the Warren Center.
This really is the most exciting time in human history. That's not a novel thing, that's not a cliche. I genuinely believe that this is the most exciting time in human history, and this is the most exciting time to be an Australian. This remarkable story of growth that we've seen over the past decades has been driven by some pretty obvious things. It's been driven by big economic reform, by economic productivity, and particularly the resources boom. I come from a farming family. My brothers work in the coal mines. This is a great story for our country. But if we are going to continue that path, we have to diversify our economy and we have to embrace innovation in everything that we do. There is enormous opportunity for our country, and this is an incredibly exciting time to be part of that. So I just wanted to say thank you so much for having me here. Please be part of this discussion. All Australians should be celebrating innovation, and I think if we can do this collectively, our future looks very bright. So have a great conference.
Tonight's lecture will be presented by Professor Salah Sukkarieh. Salah's work is a shining example of what is possible when industry and academic research collaborate. Salah is an international expert in the research, development, and commercialization of field robotic systems. Please join me in welcoming Salah to the stage now.
Thank you, Ashley, for the introduction. Ladies and gentlemen, thank you for coming tonight. It's truly a great honour for me to be talking in front of such a distinguished audience. And as technology is advancing, and it's advancing very quickly, even for someone like me who works on it on a daily level, trying to keep up to date with what the latest technology is can be quite difficult. And in a world where there's lots of chatter at the moment now about how automation is going to affect whether it's employment and education, it also affects commercial industries, because it's not just about them adopting technology in some way, but it's how you kind of have the innovation pipeline through that, through the commercial or the business models that you have to look at in order to maintain that process through. Automobile manufacturers have been working on autonomy for a long time. It just hasn't made any commercial sense to kind of pop that out. What Google has done is been able to drive that out forward and really say to the regulation and to the policy making, look, we've got these autonomous vehicles coming through, what are we going to do about it? And that's really just spurred on the rest of the automobile manufacturing come through. Volvo reckons that by 2017 they'll be able to have autonomous cars out there. This is our entry in 2006, 2007 into the DARPA Grand Challenge. Take a vehicle, start putting a whole bunch of different sensors on board, and then all of a sudden you start doing the things that I showed you before, autonomous driving. The reason why it's driving on the right is because the DARPA challenge is in the US, and so we had to train up the vehicle to kind of just drive on the right. But it's doing various things such as sensing the environment around it. It's being able to detect individual objects. So here the different colours and the different boxes are representing the vehicle being able to identify what's a person, what's a bus, what's a car, and tracking all those systems. The Baxter robot, developed by Rethink Robotics, just came out earlier this year, late last year. Rodney Brooks, who's an Australian CEO of this particular company. It's an excellent kind of example of what robotics can do in manufacturing. It's meant to be sub $20,000. You grab the arms of this robot, you move the arms, it learns all about the joint movement. It's got a camera that's looking forward as well, and really what it's doing is learning what you're doing so that you can then let it go and you can retrain this robot to do various tasks in the manufacturing cycle. Whether it's Amazon delivering books or Domino's delivering pizza, DHL want to deliver parcels. We've heard lately about Australia Post as well doing the same thing. A classic example of where technology is already there, ready to do something, but it hits it front with regulation and trying to deal with regulation and policy issues and allowing that to happen. This is Bonnie Rob, a vehicle that's been developed by Amazonian Bosch. It's a vehicle that's meant to be used in the agriculture industry, being able to monitor weeds, crops as well, looking crop yield information. This is Cheetah, developed by Boston Dynamics. It recently been purchased by Google. This vehicle here, it's meant to look like a bit of a blur. It's actually a four-legged robot, and it's travelling at 45 kilometres per hour at this point here. To maintain stability and agility is quite a difficult problem in dealing in space. And if you look on the web, you'll see many examples of that. So when we look around the world, there's lots of innovation happening in this space. Startups, universities, government agencies, science agencies, commercial entities, all building ground vehicles, air vehicles, underwater vehicles, humanoid robots. So space is quite populated with a number of different examples. The world is uncertain, especially when you're dealing with robotics working outdoors, and because of that we need to model the world in that uncertain fashion, and we've got to make, and robots got to make decisions under that uncertainty, and that's a very, very difficult area to work with. It's really trying to determine for the robot the level of risk that it will take under certain situations. The first one that I'm going to look at is stevedoring, and if you're at the 2010 lecture, you will have seen some of these. I've changed it a bit to sort of kind of emphasise some other aspects in this space. This is some footage from the Brisbane automation terminal. There are between 30 and 40 straddle carriers now moving around 24/7, picking up containers, dropping off containers all autonomously, and doing so in all weather conditions. The same technology that we developed back then in 1999 is what's being used, the radar systems, the GPS systems, and all the control technology that sits on board. You can see the black lines on the floor. It's so accurate, within plus or minus a couple of centimetres, that it traverses over the same areas. It can stack up to 3 containers high. So when you have 40 straddle carriers moving around, communicating, telling each other what's going on, where the containers are and so forth, you can start to get a bit more of intelligence going in that operational space. One of the biggest gains that you can get out of this is being able to predict ahead of time and seeing what the operation will be a few hours ahead. And the reason why is all the algorithms that are on the robots, all the algorithms that are in the system out there are also the algorithms that you would use in your simulator. So if I predict 6 hours ahead of time and say this is what my operation will look like, I can almost guarantee that's what the operation will be. And that type of perfection, that type of accuracy is really what gives us the advantage. In this case here, we're also talking about 40 straddle carriers trying to pick up, whatever it might be, 5,000 containers. And how you deal with optimization in that is also, we looked at a lot of economic theory and trying to feed that into it. In this case here, we found that one of the best solutions was a reverse auction algorithm, so the containers themselves bidding for the straddle carriers was a lot more efficient than the other way around. And so you start to get these processes that you can feed in. And economic theory is really good for us as roboticists, because economic theory believes that we are all rational beings, which we're not, but robots we can actually program to be rational, so it actually works quite nicely in that space. Our first interaction with mining was all about safety. Okay, that was what the big thing was back then. How do you ensure that the trucks drive around the mine site quite safely was a significant thing. And we dealt with a lot of different aspects, building radar systems. In this case here, there's a little laser unit on the side there. There was a spin-out that came out of the University of Sydney called Accumine that looked at developing the technology to maintain safety in systems. The next area I'd like to talk about is agriculture and the environment and the work that we've been doing in that space, and this has really kicked off over the last 2 or 3 years in this domain. Here is an unmanned air vehicle, a drone. It's fitted out with a number of different sensors, and this was a project that we had with Meat and Livestock Australia around being able to collect large spatial information down at centimetre accuracy. And this is an example of a map that we've been able to build after a flight trajectory. So building up a map with centimetre accuracy and then being able to pass that information to machine learning algorithms, and those machine learning algorithms will automatically detect what are the different types of vegetation in that environment. So the different colours here representing different types of vegetation. Really what's of interest here is being able to detect invasive weeds, so in this case here woody weeds, from the native vegetation, and being able to map that out quite accurately. Every year there used to be a NASA robotics challenge, which was looking at being able to mine on the moon and being able to use robotics for mining on the moon. Okay, you can see where their thinking is going in that space. Again, what I'm trying to enforce here is that there's some smart kids out there really doing some really talented things. If you can kind of encourage that, and if you've got something like the ACFR that's feeding in behind it, you can do a lot within that space. Most of our robots now are about 20 to 30% 3D printed. It won't be long, we're already talking now about how we're going to go start using 3D printing in that space. And that's going to change the way we do things. Instead of outsourcing and a lot of times offshoring a lot of the production of the robots that we do, we're going to be able to start doing that in-house. There is an item that's used in construction, on your left, and what's on the right is something that can carry exactly the same load but with 75% less weight. What they've done there is you can't manufacture something like that in normal processes, right? But you can 3D manufacture something like that. And think about the scenario where there are robots working in the environment, and as they're working in the environment, they might have their own internal 3D printer and print certain things they need to work in that particular environment at any particular point in time. For example, changing an end effector on a robotic arm given the situation that they've got. These are some of the things that we'll start to see in the future. So what are the areas that I think over the next few years are going to really drive robotics? And that's important for us to understand, because this being my final slide, I really want to be able to talk about just a little bit, for about a minute now, about what this all means in this space. If robotics now is changing the way we have to think about STEM and jobs and employment and what it looks like in the future, then what happens when we're also rapidly changing what robotics is as well and what automation is as well?
What about those young people, old people, who are not so bright, not capable of developing the algorithms, and particularly when it comes to developing countries? Because they're being educated now to get to the stage where they can run a call centre or whatever in the Philippines, or do outsourced typing. Once all that becomes robotic, what will they do? Where do you see the jobs coming for those sort of people?
I really don't know the answer. I do know that there's some major shifts that are happening, and they will continue to happen. As I showed you what the future trends around robotics is looking like, that's going to affect the robotic technology, which is going to affect us even more on a social, economic perspective. So I don't have the answer, to be honest with you, in that space. But that's something that we hope to start to address. It's great to hear the innovation talks that are happening from the government. It's great to hear STEM, but there has to be something more deep than that about the relationship between all of those things. And I think we're missing out on that type of discussion, and that I think we need to address.
Before we move next door for final drinks and canapes, please put your hands together and thank our sponsors, Swab Attorneys and University of Sydney, and our speaker tonight, Salah Sukkarieh.